Hey everyone, this is Mrs. Brannick. I will be videoing the lessons for you during this continued learning time. Today's lesson is the first lesson of chapter 7. It is on exponential functions. So the first thing you were to do was a sort. Once you sorted the items, this is what you should have ended up with. Now, as you're looking at the growth side, you can see that growth graphs are increasing, and the multiplier here is greater than 1. As our x values increase, our y values are increasing. So these are going this way, these are increasing. Same thing over here. Someone is raising 2 butterflies, the population, that should say doubles every 2 months. Okay, so now let's look at the decay side, decrease, and our graphs are going down. Our multipliers here are less than 1, whereas on our growth side they were greater than 1. As x is increasing, our y's are decreasing. Billy currently has $4 and this one was, but I think he's losing a certain percent each month. Okay, so this is kind of a review of what we did in chapter 5 with sequences, only instead we are looking more at, instead of discrete data, more continuous. So our graphs are going to be lines, not dots. All right, so let's move into the notes here. Now you can print these off from either going to the link that is in your assignment. Your teacher may have posted them also in Schoology or Google Classroom. You don't have to have the notes like this. You could simply do them on separate paper. Completely up to you, whatever's easiest, whatever you have access to. Okay, so in this lesson, we're going to investigate the characteristics of the family of functions of y equals b to the x. Now, a lot of these questions in here say, as a team, do this, as a team, do that. Keep in mind, you're just listening to this video. Okay, so beginning to investigate exponentials. So in chapter 5, you graphed several exponential functions. Some graphs look like those modeled by the rabbit population, if you remember those problems. In problem 5.4, we're increasing exponential functions, and they look similar to these. Okay, so these were increasing, such as the rabbits. Other graphs, such as the rebound height graphs, like the bouncing ball that we did in the, I believe that was the second lesson of chapter 5, and it represented a decreasing function, which looks similar to this one right here. You already know that the equations in the form of y equals mx plus b represents the family of lines. So that would be a linear. And you know what effect changing m, which is your slope, will change the degree at which it's slanting up or slanting down. And b is your y-intercept. So that can shift up or down as well. Today you're going to begin to learn more about the exponential function family. In their simplest form, the equation looks like this. Y equals b to the x. There is secretly an invisible 1 right in front of that b. Okay, so we're going to talk about this equation in the next couple of problems here. So by experimenting with different values of b, find 3 equations in y equals b to the x form that have graphs appearing to match the 3 graphs shown above. Confirm your results using your graphing calculator, or you could use Desmos. Okay, so if you had access to that, you'd want to play around with some numbers. Now what you're going to find is that for these first 2 graphs here, and just playing around with the b value. Okay, so just changing this number here. Now we know that in order to increase, the b value has to be greater than 1. So if I took my calculator, gotta charge this sucker up. Yep, I guess I'll have to do that on another one. My battery's dead and I don't have a charger handy at the moment. So if you typed in y equals 2 to the x, say y equals 2 to the x, and this one might be, say, y equals, whoops, that should be an exponent there. And I'm just really screwing that one up. 0.5 to the x. Okay, it's not increasing as quickly as the 2, so that's why I chose a number smaller than 2, but still greater than 1. Where this graph here is now decreasing, I know my b value has to be less than 1. So let's say it's y equals 1/2 to the x. Okay, so in its basic form, and I'm going to introduce the a value now just so there's no confusion later on down the road. The a value is really your starting amount. How much are you starting with? Like how many rabbits were at month 0? What was the height of the ball when you first dropped it? Okay, and that's also maybe our y-intercept. Okay, in the b value, that's our multiplier. If b is greater than 1, we have increase. If b is less than 1, we are decreasing. Okay, so what other types of graphs exist for equations in the form of y equals b to the x? So with your team, you're going to try and find different values of b to find as many different looking graphs as possible. Stick to values of b that are less than 10 just to keep it simple. Keep the window on your calculator set from -10 to 10 in both the x and y direction. That's, of course, if you had your calculator. Okay, so what you're going to find is that simply this is really just a review of what we've already done. That when your b value is greater than 0 but less than 1, okay, you're going to get a graph that is decreasing. If you have a b value greater than 1, you have a graph that is increasing. So this could be, for example, y equals, 2 times 2 to the x. So it's doubling starting with 2. And since I went through the 5 right here, I'll say this one is y equals 5. And how much is it decreasing by? I don't know. I'm just guessing because I sketched it in. It's just got to be a number less than 1. I'll say it's about, we'll say 1/2 to the x. Well, what if my b value is equal to 1? So let's say I started with 3, but my b value is 1 to the x power. Well, 1 to any power is still 1. So if I simplified this, it's really just y equals 3, and you get a flat line. Or I should say a horizontal line going through the y value of 3. Well, what if your b value is 0? Well, if the b value is 0, let's say it's 1 times 0 to the x power. Well, any time 0 to any power is still going to be 0. So y is going to equal 1. It's going to be a dot. Okay, so you really can't have 0 as a multiplier. And if you have 1 as a multiplier, it's not an exponential either. It has to be less than or greater than 1 as your multiplier. Okay, the graph of the function right here is shown at the right. Describes what happens to y as x gets bigger and bigger. So for example, what is y when x equals 20 or 100 or 1,000? So if I were to write this out, y equals 1/2 to the 20th power. or y equals 1/2 to the 100th power, or any larger and larger number, the larger this number is here, the steeper it is. It changes the steepness. How quickly it increases or how quickly it decreases. Okay, so part B, does the graph of y equals 1/2 to the x have an x-intercept? In other words, will it ever cross the x-axis? Well, what is the y value along the x-axis? That would be a y value of 0. Can 1/2 to the x power ever equal 0? And the answer is no. So we call this graph will approach the x-axis but never cross it. So the x-axis is a horizontal asymptote, meaning it's never going to cross. It's going to get closer and closer and closer to x equals 0, the x-axis, but it will never cross it. When x is very large, the graph of y equals 1/2 to the x approaches the x-axis. That is, the x gets larger and larger, farther and farther to the right of the curve, and the closer the curve gets to the x-axis. In this situation, the x-axis is called the asymptote. You can read more about this in the math notes at the end of this lesson. And they are right here on the next page. So does y equal 1/2 x have a vertical asymptote? In other words, is there a vertical line that the graph above approaches? So will this graph get, if it keeps going this way, what vertical line is it going to approach? Well, there really isn't a vertical line here. So that vertical line is non-existent. There is no vertical asymptote in this case. So looking at the learning log here, how does changing the b value affect the graph? Well, that b value is your multiplier, and it will decide if it grows or decays. So if it's growing or decaying. So if it grows, the b value is greater than 1. If it decays, it is less than 1. An asymptote is a line a graph approaches but never crosses. It gets closer and closer and closer but never crosses. And then here's more information about asymptotes at the bottom. They don't necessarily have to be the x or the y axes, as they've shown you here in these other examples. There are other asymptotes. It could be a graph. It could be a diagonal line. It could be another horizontal line that isn't the x-axis, or it could be a vertical line that is not the y-axis. Don't worry about asymptotes that are not vertical or horizontal. We will only be looking at these two types in this chapter, but we're not going to go into depth with them. Okay, that is it for your lesson for Monday. I am going to just go through some of the review preview problems to get you going. The review preview problems